Good afternoon, sir.
Hey, TT, how are you doing today?
I'm fine. How are you?
Oh, jeez, I'm under the weather again. Oh, Lord. Oh,
Sir,
why?
I woke up with a dry cough this morning.
Uh-huh.
I was really sick this morning. I had to take some medicine. Kind of feeling a little bit better.
With tea? I don't know what kind of medicine you taking because clearly the ones that I taking not working. Last week, Wednesday, I I had a dry, no, not a dry cough. I had a slightly sore throat and got home. I was on campus, got home, gargled. By Thursday, it manifested. The weekend was nasty. Yesterday was awful. So I'm giving thanks. Today is not such a bad day, but I'm still having the effects of it. I got up with a terrible headache this morning. Oh God. But let us see what will happen now. I believe it's the heavy rains that we are having or the change of climate pretty much it is causing what is happening. Or I hear somebody saying yesterday that there's a terrible thing going around, but trust me. I taught a class. Oh, you were in class on Saturday. I, no, not you. No, it's not you. It's my CAPE students that were in class with me. I teach a business calculus class on a Saturday morning, and then I invite my CAPE students to come in with me. Class supposed to end at 12, and minutes to 12 o'clock. I have to say to them, hit a plan. One, and I just lie down and just drop asleep a little bit, and I have been sleeping ever since. It's rough, man. It's a rough period.
Yes.
but I'm happy that you are feeling much better. What I find is that you tend not to eat when you feel like this.
Yeah,
For me,
I didn't
so,
eat the whole day until a while ago.
no, is that the wicked something you want?
I never had any appetite when I was going to force myself to eat.
No, Tiki. You know why I can tell you that? Because I was at that point. I would just wasn't eating. I don't want no food. I don't. I just don't want to do nothing. But no, man, you have to eat because this is what this wicked thing wants. It just knock you out cold. So you have to get something to eat. You have to eat. I mean, if it means that you have to put on, you know, some chicken noodle in a one look of something and just get a look of broth. But we have to eat and keep our stomach warm and filled. And don't take any tablets on any empty stomach, please.
Yes.
Yeah. All right. Guess what? I don't know how much longer I will be able to last out. So what I'm gonna do is early birds catching first worm. Let me just go through this with you as a review to what we did last class. When the others come in, they can join us. I will leave a fresh example um, so that they can see the fresh example. But since we're here and I am here, there are four of us in total. Yes, Abby, how you doing? Let me let us just begin. Um, I can just talk to you about share screen. I can just talk to you about some of the things that we did last time around by just going through um, one of the questions that we did. This is one of the last things that we need to do. I know I have a science matrix to do, but it's one of the, we're kind of wrapping up. And what I want to do is I just have one other example to give you. And I want us to go through some past papers. I want to get into the past papers with you. So tonight, I'm hoping I could use the first hour to just wrap up this one example. Then I do, even a half an hour worth of past paper questions, we just answer random questions, to put in a position to be better able to answer these questions. All right, so let's just go. So the last time around, we looked at Lagrange multipliers, and again, I told it was another way of optimization. Now we looked at the multivariable functions in one other sense, where we were able to optimize our function. So this is another type of question, and I want to just point out some things here. Let me get my spotlight. So you have f of xy is equal to 5x minus 3y. F of xy is equal to 5x minus 3y. So it says find the maximum and minimum. Find the maximum and minimum. This is f of xy. And it is subject to the constraint x squared plus y squared is equal to 136. All right, look at what we're doing. Remember, it's a question on applications of differentiation. All right, so this 5x is going to be corresponding to this x squared. So 5x, when I differentiate 5x, I'm going to get 5. See the 5 right here? So when I differentiate x squared, I'm going to get 2x. What becomes 2 lambda x, because I have to put lambda as a constraint, right? So it says, how do we arrive at these questions? Not lambda is a multiplier, it's a Lagrange multiplier, which is what I'm going to be using. So I'm using lambda as my Lagrange multiplier. All right. And then now that's one equation. That's one equation. Let us look at another equation. This differential of negative 3y is going to give me negative 3 right here. And the differential of y squared is going to give me 2y. But of course, I have to put lambda to it since it's my constraint. So I'm going to have lambda 2y. All right. So that's how we got these two equations. Now, and of course, given this constraint, x squared plus y squared is equal to 136. So these three equations, now I'm going to be working. All right. So we're going to investigate the differentials. We're going to investigate the differentials. So remember, lambda cannot be equal to 0. So we can solve the first two equations for x and y respectively. Now remember, 5 is going to be equal to 5 is going to be equal to 2 lambda x. 5 is equal to 2 lambda x. I need the value of x. So I'm dividing both sides by 2 lambda. So I'm going to have 5 over 2 lambda. See it right here, so? Everybody see that? Somebody talk to me, please.
Yes, sir. So it's
Cool. Yeah.
okay.
So yes, good evening, Andrew and Yannick. So and again, I'm going to be solving for y. So why are you solving for x and y? Remember, I have my constraint. My constraint is what is going to tell me what it is that I'm supposed to be. Put it this way. Put it this way. So we are going on a trip, on a class trip. And I say to you, once we get to the resort, nobody should leave the resort. That's a constraint. No one is permitted to leave. Sir, but may I beg somebody? Okay. So if it is that you are having a challenge with that simple instruction before we depart, don't come. Because whether or not we are adults, I would say, and especially if the school bus takes us, I would say we are going under the auspices of the ECC. So you will have to have a reporting officer representing the ECC. That will be me as a teacher. So if I say to you, now left the compound, it means say nobody should leave the compound. All right, that is a constraint. That's the constraint. So we are going to go inside. And I mean, of course, there are ways we can get around that. Sir, here's the plan. This is the situation, and so forth. I'm saying, yeah, man, we can do that, whatever the situation is, right? But the
But
constraint
sir,
is, yes, sir, go ahead.
in situations like that, if they want to leave the compound, they need to inform you,
Which is what I'm
right? So you
saying,
know.
right? Yeah, which is what I'm saying. But in normally, oh boy, normally when we say things like those, and which is why personally, I I have a problem. Adults are no adults. I have a personal issue in taking people's family members, students, outside of compound of the ECC, because when students, irrespective of how young or how old they are, once they get out, nobody can talk to them. Nobody can talk to them. I remember taking some students they did very well. And I said, you know what, plan a trip to Puerto Rico. And we went on the school bus, we went on to Puerto Rico. And, to be honest with you, when the bus reached at the beach mouth, before we come up on the bus, we said to them, we said, hey, this is the situation. Mr. Shand is the official representation here of the ECC. So somebody tell himself, come out of the water, and I go, come out of the water. And when you decide, say, of course, you go to the beach, them have a little barrier with the buoys there, don't pass right there so. Because this so is deep. And him want show off, say him can go swim. But when I look out of something there, and I don't know if he was embarrassed, but when I shout him and say, yo, come change your clothes and come hold a seat. He never did like that. But guess what? Me not going to go save nobody. Straight up. So I personally, from that year until to the day, some 25 years now, I don't do it. I mean, if we want to plan something, on a find here on our own, we can say it's something that is planned outside of the ECC. Then I can do anything I want to do. But once we go under the auspices of ECC, no man, the rules have to be abided by, man. Trust me, real talk. But the point though is this x squared plus y squared, Andrew, equals 136. You cannot go outside of that. If you want to go outside of that, you're not optimizing your product. And I keep saying to students, I don't know how many of you can identify with this, but how do I say this? When I think of you going into a store, but be it local or overseas, and you may look at a pair of Adidas, a pair of adult Adidas. A pair of adult Adidas may cost about $39.99. Well, for sure, the ones that I've looked at when I go to like Foot Locker. And you're walking through the store, and then you buck up a little infant side, and then now you recognize that the baby Adidas is $59.99. I say, but hold on there. Them use more material make the adult one than the pitney one. So buy my one is $39.99 and for them one at $59.99. And then I said to myself, we not take up $60 buy one shoes, one little baby, and then 2 weeks only let the fit the foot grow big and we can't wear it or she can't wear it. What are your thoughts? Has anyone ever seen something like that? No, yeah?
Yes,
Yes,
sir.
sir.
Yeah,
Mainly
man.
for those who have kids.
Right, but guess what? Why think it? And you don't have to have kids for you to see it. I mean, you can just be very observant and go into the store, see a pair of Crocs for a child sometimes costs the same money as a pair of Crocs for an adult. Why is it that you think the infant clothing is as expensive as the adult clothing? Let me just give one example and see if you guys are thinking as we speak of optimization.
Well, sir, only thing I can come to is because they of the size.
Of the
Because
size?
when things are smaller, it's what it takes to
Mm-hmm,
put it together, right, takes
mm-hmm,
time.
mm-hmm, mm-hmm, mm-hmm. That's one
So
plausible
it's more intricate to put it
very
together.
better. I was going to use the word intricate, but I said leave you alone. But yes, that's one plausible reason. Is there any other? Here's one other that I'm thinking of. Yeah. So the intricacy of making a shoe is going to be it's going to be a little bit more than what it takes to make the adult one. Yeah. What else? There's another blaring one that one can think about. All right. Let me ask you. When you go, how many adult pairs of shoes you see on the shelves compared to the number toddler shoes you see? How many? Do the comparison.
So you have more for the
They have
child
more
than
adults.
adults.
You have more for the child than adults, or more for the adults than
No,
the
in
child?
fact, it's more for the adults and the child. Because if you look into a playlist,
Yeah.
I see a small section for children,
Very good.
and the most of it's for adults.
Yeah, and that is socials. You may have more for the children than you have for the adults. So that's another reason why it is so expensive, because they're not making them in the quantity that they will manufacture for the adults. So for adults, they may make 100 pairs, but for children, they may only make 20 pairs. So in order for them to compensate, because remember, even though they're making 20 pairs, the chances are they may use, because it's more intricate, they may end up using more electricity, because it is going to take a longer time, as Andrew says, to manufacture. So you'll find that just to manufacture one pair of toddler shoe, they could manufacture maybe 2 or 3 pairs of adult shoe, because the time it takes to get all of that, intricate detail, just to let it come off and look good, so to speak. All right, because the bigger the thing is better for you to be able to manipulate, etc., etc. So, and one of the other reasons again is that they don't manufacture a whole lot, so they have to compensate, because the truth is, um, if it takes more time, the resources are going to be equally the same, if not more. Equally the same, if not more. Right? Let me just use a very touchy example. So, not all community colleges charge the same amount of money for the same program. All right? So you may be doing a BMIS or a BDIT, and another community college may charge $10,000 less. And you may say, but why Excelsior is charging so much money? The truth of the matter is, the other institution may not have the facilities that we have. To do the program at UTech or UWI, it's more than doing it at Excelsior. I may say, never go at Excelsior because you are charged too much or UTech are charged too much. The reason is the facilities that UWI or UTech has or have may not be will paid into comparison with what Excelsior Community College has. They may use some of the latest software that poor ECC don't invest in. So because they have to use Linux and them something there they call them, because we may not use those, and UWI or UTech may invest in purchasing those things. It's an additional cost to the UWI and UTech, so their fees are going to go up. Final example: you and I riding on a plane. My plane fare does not equate to your plane fare, right? So we may be sitting in first class together, side by side, and you may look and say, oh, he must afford first class ticket. Chances are he may not have afforded first class ticket, right? Flying at the back of the plane, you'll get there the same time as the front of the plane. So I'm just saying this to say to you, it is called optimization. I did say final, but remember, I don't know if any of you remember the days of Spirit coming up with $9 fares. I may wonder, I can tell you, I have been beneficiary of one or two of those $9 flights, but and it's not $9 a pay. You have to pay $9 for both legs, yeah, but you have to pay tax that would come up to about 100. Them days maybe $120 or so. So you're paying about $130 for a plane ride, back and forth to Florida. So them the days they could just fly up for a weekend. They leave Friday and come back Sunday evening, because it was relatively cheap. But the truth of the matter is, with the name, Spirit knew how to optimize their fares. So they dropped the thing. But your own carry-on that you normally put in the overhead on the plane, you had to pay for it. You had to pay for it, and you had to pay like either $25 or $35 for it, right? So, and if you're carrying up 2 empty suitcases because you're going to shop until you drop, you have to pay for each suitcase. So if one can go into the other, hooray for you, you just pay one fee. So I used to say to my peeps, you know, a group of us used to just go away. And I used to say to them, I said, here the plan. Think about it. If you're paying $25 for the first piece and $35 for the second piece, that is $60 you're paying for 2 empty suitcases. Plus, you have to pay $25 for your overhead. So you're talking about $85 you're paying. Why not just pay the $25 for the carry-on for the plane, and then purchase 2 new pulley bags when they're coming back, because you can't get a pulley bag for maybe $25 or $30. It still works out to be the $60 that you get paid them in any event. And guess what? Spirit recognized that this is what a lot of people were doing. And as a result of that, their optimization just never make it at all. All right? So that's exactly what it is. So everybody goes into a business to optimize. So coming back to you, ABC, this x squared plus y squared equals 136. When it is that Spirit and the other people then can go outside of that, this is going to be the constraint. So what the airlines do, don't know how many of you know about it, but what the airlines do is when the fares come out, they will pay the first number of passengers will take charge of the flight. I mean, in terms of cover every time they land at an airport, it costs the airline. So it takes into consideration that sort of fee, etc., etc. So when they recognize that the flight is open 2 weeks now, and the plane can take say 200 passengers, and it's just 50 passengers would have bought the ticket so far. The flight can go, but 50 passengers may just be a break even. What the man they may do now is say, here the plan. Reduce the rate. The flight is $600. Like 2-3 days before, they may drop it to $400 or $500. And somebody may say, geez, on the flight, drop and purchases a ticket, right? Now, you who bought a ticket early may pay a little bit more than that, but the company now recognize that here the plan. Instead of flying the plane with only 50 passengers, what if I were, and I know I still have to fly the plane because those passengers pay for the stuff. What if I were to drop the price closer to my departure time so that I can get maybe 50 more passengers that may pay even half the fare? It is still more money that the companies get it. So they know how to optimize the stuff. So when you're, and you guys are in IT, don't know if you recognize it. If you go like on Expedia to check a plane ticket, Expedia recognizes your IP address. And if you go back to look at the ticket, that ticket price goes up. But if you use another device, you will see it at the original rate that you saw it for, right? So it's a lot of, you computer whizzes, there are a lot of tricks and trades in this business to optimize sales, right? Because what the company is saying to you is, don't leave. Oh, trust me, them Spirit right there. Yes, I agree with you, Jermaine. Them Spirit right here. Why I stopped taking them? I made a confession to God one day. I said, God, if you take me out of this plane alive, I will never go back on another Spirit flight. And I came out, and for years I didn't fly with them until recently. I don't know why, but we kind of go back with them one more time. I think it's me to go. Anyway, I know we had, I think I went on Spirit once again recently. But them rides, very rough, man. Rough. Them pilots, they come like one Jamaican taxi man. Them, no, man. Them dropping a pure patrol in the ear. Jesus, God. But anyhow, so we are optimizing. So I'm seeing more people joining. So let me just point out some stuff that I pointed out earlier. This is my multivariable function, f of xy. and it's equal to 5x minus 3y. And this is my constraint. ABC and I were having a conversation that sometimes we can go outside of the constraint. But I'm saying for the purpose of this thing here, we can't go out of the constraint. And like for the purpose of manufacturing those baby shoes versus the adult shoes, they may not go out of the constraint. For the purposes of an aircraft, an airplane, selling airline tickets, it is easier for them to go outside of the constraint because they have already made their money and break even. I think I've told this class before, or maybe not this class, but when I'm teaching this topic to another class, there are days when I'm at school, of course, when I had a face-to-face regularly, and I'll feel for something, nice to have for my lunch. And I'll drive into New Kingston, and then when I get to New Kingston, I say, Lord, them fried food with oil from last month, not gonna buy it. And New Kingston is not even the nicest place. Too many rat-sized mangoes or mango-sized rats up there. So I'll opt to go into the supermarket. And what I'll do is say, you know what, let me just buy maybe some fruits and some yogurt, or just try to go healthy. And sometimes I'll go into the fridge and I will see 4 tubs of yogurt banded together. Buy one, you get 3 free. Hello, that's my type of game, right? So you buy one yogurt for like $250 and you get 3 free. And I said, okay, we know that the expiry date is very soon. And I'll look at the expiry date and I'll see that it's expiring in 2 days. I know I'm not going to eat off 4 of them, but I can buy one. It's not going to kill me because I'm really going to buy one. I'm still paying for the price of one, but I'm being given 3 more. But go to school and I say, oh, you eat yogurt? Them say, yeah. They say, you're the plan. So one year, if you don't eat it today, no, make sure you eat it tomorrow. It'll go bad. And I'll just go and just purchase the yogurt and go. No, you may say that the company is losing money. The company are not losing any money because when they're buying their yogurts, if they buy 10 cases of yogurt, chances are after them sell 5 cases or 4 cases for that matter, the other 6 cases is profit. So what they do first is take out back their money, and they know what is left after is profit. So if them have 2 cases out, they would have still made a profit. So they're saying to themselves, better we give the customers free than we have to throw away. And that's what the banks do. When you borrow a loan, which is why mortgages are so darn expensive, when you borrow a loan, what is happening is they are taking their interest upfront. So you take a loan and you pay $150,000 amount. And you take a $1 million loan and you pay $150,000 amount. And say, yeah man, 6 months on it. And you say, no man, I must about $800,000 for payback now. And when you go take a little, hello?
Sorry, not to cut you. I apologize. But I think this was interesting. So I went to the bank and I was inquiring about a loan. Like I was asking him, like, if I take out a loan to purchase a house, how much would I have to pay back or whatever? So he told me, like, if I take out, for example, a $10 million loan, I have to pay like $70,000 a month for like 30 years. What?
Yes, miss. Yes, miss. Yeah. But guess what? Nobody has that. Well, sorry, let me not say nobody. People like me and you can't find that money cash, so we have to go through it. The man them who is rich can pay the $10 million cash. But for people like me and we have to go do it. So that's why it is the poor man that always gets that dirty end of the stick. But the truth of the matter is, you paying that $70,000 and $70,000 so cheap, really and truly, because at a $10 million, you're looking at a $10 million loan now, you're looking at almost $90,000, $95,000, $100,000. But okay, tell is $70,000. So let us work with the $70,000 for 30 years. Here, what is going to happen now? You see, after year 5, I guarantee you that you're still going to be owing. You would have paid about less than $500,000 to that loan after 5 years. You'd have paid less than $500,000 on the loan. So you're going to owe $9 million on the loan, right? Because what happens? That $70,000, you're going to pay about $65,000 plus on interest alone, if not $69,000 on interest. and it's like about $1,000 went towards the principal. Trust me. Believe every word that I say. That's how it works. So so I keep saying to people, if you're paying a mortgage, no matter check not until like 10 years, 15 years into the 30-year mortgage, you should go halfway. And then I also say to people, one save, and then after that, no, if your mortgage company can take lump sum payment, then you put lump sum payments to it. So it is that you can reduce the principal, or to see if you can clear the loan after a while, because it's expensive. They are optimizing what it is that they can get out of you. And guess what? When interest rates go up, if you are not locked in at a particular interest rate, dog never suffer, because it's going to go up with you. So they are optimizing even more, because you may take the mortgage at 6.5%, but cost of living gone up or interest rate gone up to 9%, and you're paying more money on your money. So your $70,000 may not go up, but guess what? You know, have to go pay for it like 30 something years, or they may say to you, this is what is happening, and there is an increase, and you have to pay more now for your insurance, because once you take out a mortgage, you have to take out the insurance. It is a tricky stuff. It is a tricky stuff. All right. But Ryan, in this chat, talk of inflation now. Check with 30 million. That's why I'm happy that I know people like you. So when
Sir.
Yes, sir.
But I tell you, I have been paying my mortgage for almost 11 years now,
Mm-hmm.
And I only borrowed 4.25 million. I'm still owing about 4 million,
Ryan, so you can agree that what I am saying is no make-up story, don't?
No, sir,
and I'm saying to you, why they are doing this is to optimize the stuff. So I will talk to you outside, Ryan, to tell you how you can bring that down in a jiffy. After class, I can talk to you about that.
All right.
No, include me in that talk that we just sir from one day night, No man,
All
serious, okay. Me just start my one.
No man, trust me, we can talk. We can have a conversation, man. All right.
Sir, what's up?
WhatsApp. We can do it over WhatsApp, so everybody can benefit. Absolutely. All right. So, so this is the we call it now the constraint. The constraint is x squared plus y squared is equal to 136. Now look at what I mean. I want you to look carefully. Look carefully. 5x is going to be corresponding to my x squared. When I differentiate 5x, I get 5. When I differentiate the x squared, I get 2x, but of course, the lambda is going to be part of the constraint. All right? Because lambda is the Lagrange multiplier. All right? So that's why lambda in everything with a constraint. Watch this next one. When I have negative 3y, remember it's a multivariable function, all right? So when I have negative 3y, and when I differentiate negative 3y, I'm going to get negative 3. See it right here, sir? Boom. But negative 3y is going to correspond to y squared. But when I differentiate y squared, I'm going to get 2y. But of course, it is a Lagrange multiplier, so it has to be 2 lambda y. See it here, sir? 2 lambda y. And of course, now I'm going to be working with my constraint. What is my constraint? The given constraint is x squared plus y squared equals to 136. Now, having recognized that, look at what I'm doing. I'm going to be solving for x. So I'm dividing both sides here by 2 lambda so that I can get x alone. So my x is going to be 5 over 2 lambda. See it here, sir? X is equal to 5 over 2 lambda. Similarly, I want y to be the subject here. So I'm going to divide everything by 2 lambda. Sir, every time it's going to be 2 lambda? No, it depends on the constraint. So I'm dividing both sides by 2 lambda. So I'm going to have negative 3 over 2 lambda. See here, so negative 3 over 2 lambda. I can write the negative 3 like this, or I can put the negative 3, I can write the negative right here, or I could put the negative up top here. Doesn't matter. It still is negative 3 over 2 lambda. All right? And now remember, lambda is not equal to 0. Why is lambda not equal to 0? Because it is the Lagrange multiplier. So if lambda is equal to 0, say, we can't maximize, we can't optimize what it is that we're doing. And I keep saying nobody goes into a business not to make a profit. You start out to make a profit, but if you recognize you're not making a profit, the next best thing you want to do is to break even. Make back the money where you spend. That's the next best thing. Nobody wants to make a loss. So the next best thing is to make is to break even. All right. So let's go. So I'm going to plug these into the constraints now. I'm plugging these into the constraints. So it's going to be 5, all of this into my constraint. Remember, the constraint is x squared plus y squared is equal to 136. So I'm plugging in my x and my y into the stuff. It says this square, so I'm squaring them. It says negative that square, so I'm also squaring them. All right. This is what we did last week or last class. I'm just recalling because I have one more example to look at for you, and then there is. I mean, I am. Look at the calendar here. Yeah, I'm almost done with the syllabus, but I really want to spend a little time doing some past papers with you. All right, and then I just leave you on your own. I'm almost done with the syllabus. This is one of the last things that I need to look at. I also need to look at some double integration, but it's just I need to go back and look at the syllabus because how I teach. I will say to you that I'm finished, but I go back and look and say, oh, hold on, I never did do this. But from what I'm looking at now, I would have completed most of the stuff. Yes, Yannick, go ahead, hon.
Sorry, so essentially what you do is differentiate normally and include lambda in it.
Yes, honey bunches.
Okay.
Yes, honey bunches.
Sorry, does it matter where the lambda is?
So thank you for saying it, because I was just about to answer her when you came in. So you see where the lambda comes in? The lambda comes in with my constraint. So the lambda has to come on this side with the constraint, because this 2x is the differential of my constraint, so the lambda has to be on that side.
Yeah, and I know that. I just wanted to wrap up that is differentiate and include lambda. When we did the dy over thing for when you differentiated the y.
Excellent.
That's what I was just trying to wrap my head around.
Excellent. But yes, Sash. Yeah, very nice. Very nice. Proud of you guys. All right, let's go. So when I do all of that, now I'm getting 5 times 5 is 25. 2 times 2 is 4, and lambda times lambda is lambda squared. -3 times -3 gives me a positive 9. And of course, again, 2 lambda times 2 lambda is going to be 4 lambda squares. And that is equal to 136. Now, as I keep saying, remember, when you're adding 2 fractions, it's similar denominator, you put back the denominator, see here, 4 lambda squares, and then you do the operation of the numerator. 25 plus 9 is 34. So you're going to have 34 over 4 lambda squares. And that is going to be equal to 136 over 1. Whenever I have 2 fractions separated by an equal sign, I always cross multiply. So 34 times 1 is 34, and 4 lambda squares times 136 is going to give me enough lambda squares. See here, 544 lambda squares. I want to find the value of lambda, so I'm going to divide both sides by 544. So now divide both sides by 544, I'm going to have 34 divided by 544. All right, so I'm going to have 34 divided by 544. All right, so lambda squares is going to be equals to, I need to find the square root. Oh, I can break it down. 34 into 544 is going to be 116. Is it going to be 116? So when I find the square root of lambda, remember, when you take the square root of a number, it's both the negative value and the positive value you're taking into consideration here. Both negative and positive. I think I wrote a little essay for you right here saying no. Yes. No. Right, I wrote an essay down here for you. All right, because I need to go through that with you. Right. So when you take the square root of lambda, you're taking both the positive root as for the negative root. All right. So now that we know the values of lambda, we can find the points that will be potential maximums and or minimums. All right. So look at what we're doing. We know that we have 2 values of lambda. Lambda to be equal to negative a quarter or positive a quarter. So we're going back to what it is that our x value and our y value looks like. What I want you to think about, which is the which is the little essay that I wrote for you in preparation for class just now. I want you to think critical points, but it's not critical points. So in the back of your heads, I want you to think critical points. But really and truly, we're not talking about critical points. Because you see, why I'm saying that, you have your X and Y value. So when you need your X and Y value, that will give you a point. See, like right here, so 10, -6. You will think critical points, but really it's not critical points. And I'm going to tell you why I don't want you to even delve on critical points too much, because it's going to throw you off. Let's go. And I hope you're not blinking. I want you to see what is happening. So if lambda is a quarter, I'm going to say 2 times a quarter. 5 divided by 2 times a quarter is going to give me 10. And when I do the same thing for my y value now, because this 10 is going to be my x coordinate. See here, x. So that's why I have it in my x position right here. Can't go anywhere else but the x position. When I have -3 over 2 times a quarter, I'm going to end up with -6. So that's my y value. So I'm saying to you that there's a potential maximum or minimum at the point 10, -6. At the point 10, so I'm going to either maximize at this point or I'm going to minimize at this point. But this is one point to consider. Is it a critical point, sir? No, it's not. All right. Let us now investigate. Secondly, lambda being negative. Similarly, we're going to substitute in that very equation that we did before, but this time it's going to be a negative value. This time it's a negative value. This time we're getting pretty much similar answers, but the signs differ. So I get -10, +6. Up here I got +10 and -6. All right. So one of these going to maximize, one of them going to minimize. Think of these as critical points, but they are not. These are not critical points, then be. Similar to what we have studied in single and multiple functions previously. Now to determine if we have a maximum or minimum, we just need to plug these into the function. What function, sir? We're going back to the original, like we would have done. We're going back to the original, all right? And why again we're not talking about maximum or minimum? I mean, sorry, critical points, because if it's critical points, we would substitute into the differential. I mean, not substituting it into a differential. We're going back to the original, right? So that's one other point to suggest that it's not critical points we're talking about. So when I use my point 10, -6, sorry, -10, 6, I'm substituting into my original and I'm getting a negative value. This negative value is a minimum. Sir, you have been teaching us from first semester that when we get a negative value, sir, it's a maximum. I agree with you. Except that we're talking about stationary points. Except that we're talking about stationary points. We are not talking about stationary points here, no. So when you get a negative value, it's a loss. It's a minimum. And similarly, when I substitute that value in there, I'm going to get +68. That is going to be a maximum. So remember, these are not critical points. So the negative value indicating a minimum, sorry, while the positive is going to indicate a maximum value. If these were critical points, the reverse would hold true. We exclude lambda equals 0 because it would not solve one or more of the equations. Do not always expect this to happen. Sometimes you will be able to automatically exclude a value of lambda, and sometimes will not. Very, very, very important. Extremely important. All right. Now, having gone through this, I know today is just not the best teaching day because of people trying to get home. You know, having to leave work at 5. Oh my Lord, having to leave work at 5 o'clock. Oh, this is where I wanted to do it. No. Yeah, this is where I want to do it. All right, so what I'm going to do for you now, I'm going to give you a question.
Sir, this is a 5-page question. Sir, laugh.
No, I'm going to tell you why I laugh. Because you and your niece, Jordan, we don't know, only supposed to be sisters of different mothers and fathers? Because that's a question that I expect Miss Gordon to ask me. So I'm wondering who is going to come out first with it. But no, man, it's not 5 page. Put it this way, though, honey. A question like this is a question that would carry some of the big marks. So you notice when I'm teaching, what I will say to you is a big mark of this, you know. So a question on that range can carry 12, 14, 15 marks, right? And I want you to be able to maximize. I'm very optimistic, and which is why, as I said before, I'm at the tail end now of this, to the point where so far from where I'm from where I'm sitting, so far it looks like I can give you next week as your study break. However, I could avail myself to work past papers because based on where I'm sitting, I'm not seeing anything else for me to teach you. I know I have Hessian matrix, but I'm going to tell you, with the number of years I have been teaching Calculus 1, Calculus 2, or Calculus 2 in particular, I've never seen a question in Hessian matrix. I have searched all the past papers. I've never seen a question on it. But you see, with my luck, I not teach it. Because with my luck, it may come this year.
Sir.
Yes, Papa.
I understand some. Because doesn't teaching end this week?
That's what I just said.
Oh, okay.
Come on, that's what I just said. But I'm saying to you that I could avail myself for us to even meet one of the 2 days next week, so we can just run some. So we can just run some past if you want.
The Lord will bless you, sir. The Lord will bless you.
Yeah, man. We did it. Yannick and Sash and Charlene, woman handled me last semester, and I had to come in and sit in. And guess what? They never needed me because I mean they came together and you know they were doing the solutions and they kind of figured out stuff. My only concern then, and I think I voiced it, is that you know there are others who came there just to get and not to give. And you know if you're doing a little study session like that, everybody should you know pitch in and just you know give something. If you don't understand, say boy, you not understand it, you can go over again, but don't just come and just get and not to give. But I can avail myself. I've always availed myself for you guys, and I want to do the same again. All right, do me a favor.
Sir, I'm not seeing lambda on my calculator.
No. There's no lambda. Lambda is just it's just another variable that we use. So it's one of those Greek letters. Alpha, beta, lambda, gamma. It's just one of those other variables that we use.
Okay.
So it's not like even it's not like pi that you can put into your calculator and it gives you a value. Because because pi is a constant. Lambda is a variable. So lambda changes. Go ahead now.
All right, so now that I get that, how did you get the quarter, sir?
Because it's 1/16. When I substitute, when I did my cancellation here, 34 into it says 1 times 34 into 544 goes 16 times. So I'm going to have 1/16. And then because I want to find the value of lambda, I'm taking the square root of both sides.
Okay.
And remember, when you take the square root of a number, you take into consideration the positive root as well as the negative root. So that's like a plus or minus for 1/4. Got me?
At all times.
All right, at all times. All right, do me a favor. So I want to see, I did that with you last time, and I went through and we started almost like about 5 minutes past 5 because I wanted to give those who were here a little jump start. And then I saw people just, you know, kept coming in. And that's why I went over to the stuff. I want to see how much of what it is that I just said to you can be translated in you attempting this question. I just have one more question, which is this. No, example 2. I don't have another example. And I want to see how far you can go. So I can give you about 15 minutes to go as far as you possibly can with this question. And if you want, I can you just take the question out for me so I can just project the solution to the other one. Let me see how far you go with that, and then I'll go through the solution with you. And then for me, that will end our class for today. You know, and if there are any other questions, I wouldn't mind doing a little one question. Oh, I have a one question to give you, you know. I have one question to give because the true me knows that topic the most come. I have another one question for you. All right.
Did you start out your recording?
I got a little complaint. Thank you. I got a little complaint about the lack of it. To be honest with you, the gentleman that I asked for assistance was a no-show. But when I got the complaint and I explained to Mrs. Campbell that the truth of the matter is the class has always gotten the recording. I have sent the recording, but the students said to me that they are seeing no video, just audio. She says to me that I'm supposed to be looking at there are several things that are sent to me, and she says I'm supposed to take a particular note of the file name. So I am to go and look at the file name to see if it was a wrong file name that I picked up. Because I mean, it's quite a bit of the recordings that would have had just audio and no video. So I am to look at that file name. So the complaint came in. I woke up to the complaint early this morning, and I, just didn't get a chance to look at it because I went into meetings and then I'm in class, and of course I'm not feeling so well and the whole stuff. But yeah, man, I will look into to see if I erroneously picked up the wrong file name, why it's only the audio and not the video. All right. So so have you taken off the we call it the question, or you don't want me to project?
Hold on, sir. Yeah.
All right. So can I go, the rest of you?
Yes, sir.
Yes, sir.
Good.
Just by looking at this already look harder than your example.
You see, you're such a real sister, You're such a real sister. Okay, let me just give Charlene an opportunity to chime in, Charlene. Come, Charlene, your turn to take a blow at teacher. Teacher can't take enough blows, Or are you going to be my friend today? All right. This piece here is a Hessian. I can maybe just squeeze in a little that. You want me to go? All right. Let me put at this first page here. You may have to zoom in. Just to give you a little jump start here. Remember how to coordinate your differentials. All right. I'm right here. Start for me, please.
sir.
Mm-hmm.
The constraint should not be differentiated, right?
Yeah, man. Okay. You see it?
Oh,
I differentiated x squared to give me the 2x lambda.
okay.
Yeah, man.
Sir,
Yes, sir.
I kind of stuck because whenever I really there from the start.
Mm-hmm.
So my question is it that a differentiate until you get a constant for the, no,
No.
just differentiate one time?
One time, yeah. Let me give you a jump start. I don't want anybody to be stopped. All right. So you see what I'm doing here? When I differentiate the 81x squared, I get 162x. Talk to me now.
81?
It's not 81 this?
2
I
times
don't
81.
know. I add 8. Sorry.
No, man, it's 81. So this 81x squared, when you differentiate 81x squared, you're going to get, see, I don't want to show you all the solution. I just want to give you a jump start. So you're going
No,
to end up with,
that part, is the when I'm supposed to isolate the x and the y. That's where I'm stuck. No.
oh, okay, right. And then now, right, and then the constraint is where I'm going to have 8 lambda x because remember lambda is associated with the constraint. So in the other example, I should have 2y is equals to 2 lambda y. See here, 2y is equals to 2 lambda y. I don't want to give away too much. Everybody see why I get these two sets of equations? Let me go again.
Yes, sir.
All right, thank you. So this is my given equation. When I differentiate 81x squared, I'm going to get 100. I'm going to get, 162x. See it on this side here, 162x, and it's going to be equals to the differential. My constraint is 4x squared plus y squared equals 9. When I differentiate 4x squared, I'm going to get 8x. But the constraint, lambda is going to be associated with my constraint. So it's now going to become 8x lambda or 8 lambda x. All right? Now when I differentiate my function here, maybe it's a multivariable function. So when I differentiate this function here, I'm going to get 2y. See here, so that 2y here, so. But when I differentiate y squared again, I'm going to get 2y. But this is going to be 2 lambda y. Then I'm going to let x to be the subject. All right, let me help you note. And it's going to be equal to this constraint. Now, never ever, in Jesus' name, you say to me, sir, 2y equals to 2 lambda y. If I divide both sides by 2y, sir, I'm going to get lambda to be equal to 0. That is just one of the values. It means that you'd have thrown out the other value of lambda. You would have thrown out the other value of lambda. So look at what I'm doing. I'm saying to you 2y minus lambda 2y equals 0. Then you're going to factorize. What is common is going to be 2y is equals to 1 minus lambda is equals to 0. So y is going to be equals to 0, or lambda is equals to 0. Is it here? Y equals 0 or lambda equals 0. If you had done it the other way, by going ahead and just dividing both sides by 2y, you can get 1 here, so, and you just can get lambda equals 1. If you divided both sides by 2y, this 2 cancel, but the 2y's will cancel, and the 2y will cancel and leave 1. So you can have 1 is equals to lambda 1, or 1 times lambda. So you'd have only gotten this lambda equals 1. You would not have gotten this y equals 0. Right? So you have to be very careful. Similarly, I'm going to use, similarly, I'm going to, right, so I'm saying to you, be careful here not just to divide both sides by y to simplify the equation. Remember, you cannot divide by anything unless you know for a fact that it will not ever be 0. In this case, we can see that y clearly can be equal to 0 if you can divide it out, then start the solution process. You'll miss that solution, which is what I'm just saying here, right? This is often one of the biggest mistakes that students make when working with these kinds of problems. Please factorize. Do not cancel. Am I clear right here?
Yes, sir.
All right, good. And then now you're going to have, let me just show you the other piece. Then now you're going to have, all right, so, so there are two things. You have y equals 0, and you have lambda equals 1. Y equals 0, and lambda equals 1. Now, we need to investigate both. So when y is equals to 0, we are going to go ahead and substitute into the constraint, because we have to put it into the constraint. Yeah? Y is equals to 0, so I'm going to have 4x squared is equals to 9. Divide both sides by 4, I'm going to have 9 over 4 is equals to x squared. When I take the square root of this line, I'm just trying to make this thing a little easy for you. Cut. This. Just a no. No, so remember to take the square root. The positive roots. So please remember that when you're doing them something, you have to take into consideration a positive root as well as a negative root. All right. Okay, and then now when I do that, I'm going to have plus or minus 3 over 2. So that's the value of x. But I know y. I know y is equal to 0. I know y is equal to 0 from here. Remember, if we never did it, we would have missed that value. So I know y is equal to 0. But this y equals 0 gave me two values of x, plus 3 over 2 and minus 3 over 2. So from this, we obtain two possibilities. 3 over 2, comma 0, and negative 3 over 2, comma 0. Am I clear right there? Am I clear?
Crystal.
All right, but do me a favor now, though. Remember, what we have done is only to investigate y equals 0. We have not yet investigated lambda equals 1. We have not yet investigated lambda to be equals to 1. So now we need to assume that lambda is equals to 1. So you go and assume lambda equals to 1 and do the other set of calculations for me. I have done one for you just now. You go ahead and do the other set of calculations, substitute it into the stuff. And of course, let me just give a little thumbs up. Right here, so is where you're going to substitute them. Here are my x and y. Oh, I didn't write that. So you're going to transpose the equations and then substitute lambda into them and then find out the values of x and y and substitute. All right, start for me.
We're gonna put the y into the constant.
Mm-hmm. I don't even hear a sigh. No man, something not going on right.
Sure.
This one.
Plus or minus 1, sir.
Remember, we used one of the equations before, so we had another equation to look at. So we had lambda equals 1 to look at. We only look at y equals 0. So when you substitute it here, we end up getting 162. 162. Oh Lord, what was the equation? 162 x is equal to 8 lambda x. 162 x is equal to 8 lambda x, right? So we're going to get, because lambda is equals to 1, so we're going to get 162 x equals to 8x. Again, similar to what it is that we did from before. Don't just go ahead and just cancel out, factorize. So we got 154 equals 0. This implies that x equals 0. When x equals 0, I'm going to substitute the value into my constraint. Remember, you know, the constraint is what it is that you are making the final substitution in. So it is that you can get those values. So I'm going to get y squared, equals 9, and y is equal to plus or minus 3. And again, x is the one that is equal to 0, but x now has two values of y. So I'm going to have 0, positive 3 and 0, negative 3. 0, positive 3 and 0, negative 3. All right. Any questions so far?
Everything is go back now, please.
Yeah, I'm just trying to show you something here. Something came to mind. I'll come into research. Why did I compare? Because something came to my mind. What came to my mind? Okay. What I wanted to point out is that, remember, I use this equation first. Because I know somebody's going to say, sir, why didn't you use this other equation, equation 1?
But sir, I asked you if it is that we should use a constant. I didn't even realize it was the equation in that.
Come on, it's the equation. Which constant, by the way?
The 4x squared.
No man, yeah man, you have to use that's a constraint, not a constant, a constraint. Yeah.
Constraint. No.
Yeah, man. So I was correct when I answered you. Yeah, you have to use a constraint. But what I'm saying to you, hon, is that let me just make this thing a little bit more. I mean, for clarity, using using equation 2 EQUATION. Bam bam. So what I want you to do, you remember this is the equation that we started off with first. 2y is equals to 2 lambda. Why? Talk truth.
Yeah.
And then this is how we got y to be equals to 0 and lambda to be equals to 1, don't? So now, copy. Now, having done y, I need to find out the corresponding value of x. So I had to use this equation now. I had to use this equation now, using equation 1. Because if I use equation 2, lambda equals 1. Where am I? If I use equation 2, lambda equals 1, I will have 2y equals 2y. And that's a non-equation. That's an inconsistent, we call it, equation. because I've already used that equation. So now that I've finished with that equation, I have to move now to the other equation. Am I clear?
Yes, sir.
Yeah, man. So now we're moving on to the second equation. So lambda is that. So we have to now use equation 1. So anywhere in equation 1, you see x. I mean, lambda, you're going to put in 1. And then we can get x to be equals to 0. And when x equals 0 now, you're going to plug these into the constraint. So the constraint here, remember, whenever you get the values, remember, remember, Sash, in the first equation that I did, I made a substitution for lambda. I made a substitution for lambda to get an x value for my constraint. See here, lambda was equal to this. So I had to find the value of lambda and then go back now to my original question, make a substitution for lambda, and then so I can get my x and my y value to put into my constraint. It is my x and y that I'm going to put in my constraint. So my constraint is x squared plus y squared equals 136. Lambda is just that multiplier that I'm putting in. I need to take it out now, right? In this other example here, my equations are here. It's just that I didn't write it out like I did the other one a while ago in terms of x is equal to this over that. I didn't do that. You know why I didn't do it this way this time? Because I have x on both sides of the equation. And I don't want to be like that to go and cancel out. In this year example, I was able to do it because not here. I was able to do it because I only had 5 equals 2 lambda x. I didn't have x on both sides. I didn't have y on both sides. So I could go ahead and just transpose it for x and transpose it for y. In this case, I could have done the same thing, but I had to factorize because I have the x on either side. I had to factorize because I have the y's on either side. So the y here, so the y here, so the x right here, so and the x right here, so right. So both sides contain the variable that I'm talking about. So I didn't want to write it down because if I did it like that, it means that I would have thrown out one of my answers. So in this case, now I have to factorize. Got me?
Yes, sir.
All right. Now from this, we obtain 2 more possibilities. 0, 3 and 0, -3. All right. Now to determine if we have a maximum or a minimum, we just need to plug these into the function. Remember the function? Function. 81 x squared plus y squared. You go back to the original function. Multivariable function. So we say x, put in an x, we say y, put in a y. So this 0, 3, we'll put it in for here, 0 and 3, we get this to be 9. 0, -3, we put it in, and we still get, yeah, we're coming to a negative number, we get a positive number, right? And then now we had 3 over 2, 0 and -3 over 2, 0 from the other sets of values that we got from up here is what it is that I'm substituting into the original equation. I'm going to get a positive 729 over 4, and this also gives me a positive 729 over 4. So the absolute value is 729 over 4, which occurs at these values, and 9 is going to be the other absolute value that occurs at 0, -3. Yes or no?
So you said that when it's minimum, it's a negative value. And you're saying no, minimum is 9? Or
All
because it's smaller?
Very good. Very good. So 729 divided by 4 is a bigger value than 9. So 9 is going to be the minimum or the smaller value. All right, watch me now. When you look at this here, this clearly is a minimum value because it's a negative. If this were 1, positive 1, it would still be the minimum. Here is the minimum is going to be the 9, and the maximum is going to be whatever 729 over 4 works out to be. All right. So when you are doing your stuff, you know you can't go below this. So this is the absolute values that you're going to go, minimum values that you use in order to maximize. This is going to be the absolute value that you're going to be, absolute points that you're going to be using in order to maximize your stuff. Put it this way, it comes back to what it is that we're talking about, you know. When I say that nobody wants to go into a business to operate at a loss, here it comes back to what we're talking about. Remember, sir said to you that, what did I say to you? That the people at the supermarket may buy, say 10 crates of yogurt. They have sold 4 crates in the first day or 2. Those first 4 crates, chances are, based on how the man them wicked under them pricing, I noticed I say buy 10 crates, by I don't know how many of you are aware of it, but do you know that some of the smaller peeps, you know, like the corner shops and the little mini marts, sometimes they buy at Price Mart to come back and retail? Anybody knew that?
Yes, sir.
Yeah, man. Mm-hmm. So
Yes, sure.
yeah, man. So they will go and they will buy, because Price Mart is taking in stuff. It's like when high-low supermarket carrying in, say, for example, 50 cases of, I don't know, a product of condensed milk, for argument's sake, 50 cases, because they have several high-low stores around the country that they have to go send the stuff to. So they may send, say them have 5 stores and they buy 50, so they're going to send 10 cases to each of the stores. Price Mart, on the other hand, is really carrying 100 cases of their condensed milk. Because as opposed to high-low supermarket where you can go in and buy 1 item, Price Mart is telling you that you have to buy 6 things of condensed milk. You can't go buy 1, you have to buy 6. So right there and then, they are purchasing much more because they are grouping or quantifying the products, so you can buy 1 of it. So when they're buying at the penny bun, I'm sorry, but you have to go buy 1 dozen of the penny bun. You can't go to the supermarket and buy 1 penny bun. No. And if you want to go to Price Mart and say, why don't you sell 1 penny bun? It means that you're at the wrong place shopping. So what I'm saying to you is that the people them who purchasing the yogurt, they would have made their money already just by selling 6 cases of the yogurt, 4 cases of the yogurt. The other 4 cases that them sell are them profit. And it so happened that boy, the sales now go on with nothing because the other 2 cases, the customers not coming in to buy. You understand? But them check it, and this is why I have these they call it QA persons who work in the supermarkets, you know, to go and check the stock to make sure them rotate and where the merchandisers rotate the stock on the shelf. But the people them now can say, okay, the expiration date, the best before date is this, and the expiration date is that, support and so on, and them have to go. It's a process. They don't just put the food in the supermarket and just leave it like that, right? They have these health person, not health person, quality assurance persons, QA specialists or agents that will go and say, here the plan. I'm releasing these items to go on BOGO, buy 1 get 1 free, because in another 2 days they're going to go bad. We are not selling these in another 2 days. So the point is, last month when they bought it, they were able to sell off all 10 crates, and they maximized their profit. They maximize the profit. Their maximum profit could have been only 6 of the 10 crates, because 4 crates would be what them used to buy the item. So the other 6 crates are for their money. All right? Here what happened now. This month, because they sold the 4 crates up front, quick time, and they get back the money with them spend. And they sold only 4 out of the 6 crates as their profit. Their 2 cases that the 2 cases that they didn't sell, it would have been a loss for them. So guess what? They minimized the absolute minimum was what they would have sold. The 4 cases plus 1 out of each case, and them, well, it wouldn't be even a full case, because them selling 1 item and giving you 3 items free. So even though the profit is not a negative stash, that's the point I'm making. Even though the profit is not, sorry, the profit negative, that makes sense. Come on, Mr. Shan. Even though it's not a negative revenue, it is still going to be considered at a minimum, because you didn't get the maximum you could possibly get out of it. I don't know if I'm making any sense. Am I? Anybody?
Sure.
I hear you, Natasha. Go ahead, honey.
No, I'm agreeing with you.
Oh, got you. Yeah. So that's what it is. So that's why I don't want you to look at it as critical point, because you could get 2 positive values. 2 positive values. You know, one of the things that I keep saying, I may have said this to you before. One of the things that I keep saying is that I have a passion for, I just want somebody to create the avenue so we can, never come man who say at the arcade. You cannot say the plan at lunchtime and on, we do like what Curious do. Them have the whole, everywhere closed on at 12 o'clock. Lunchtime, closed down. You understand? You could have something like that at the arcade. I would say the plan come. For the show, we can maximize on the profit. Because the truth is, some of these guys, I believe, don't sell as much as, some days them don't sell nothing at all. And Stash decides that boy, she want a skinny jeans. And she go buy a skinny jeans, and the man said, a 3 grand fitting daughter. And so she said, all right, you need a 3 grand. And the man gets a 3 grand. But remember, say, in this borrow $1,000 from Germany yesterday to buy a food can never sell nothing yesterday. So as him get him 3 grand, he have to pay Germany $1,000. Because Germans, see, say we get a stealing and Germans say, boy, give him $9,000 to that, So Germany want him $1,000, so him let $2,000 more now. And remember, I said, oh, the youth them for go to school, them never, the trust lunch for them. So that $1,000 for the youth them at school. And then now he said, boy, that $1,000 I keep safe, something, because until you know, I come and work tomorrow. The man did not sit down and say, instead of $3,000, 10% or 5% is going to go back into the business. The man never the money same time. So when he or she is ready now to go and replenish the stock, it can't happen. It can't, because they don't have the money. But I know some of them do is say they might go throw partner. So in the same arcade, them throw their partner, and the partner where them show now is going to be used to when them get them draw, they're going to use that now to replenish them stuff. Right? But it is important that you do your inventory. It is important that when you, for example, go to Curacao, when you go to Curacao and what I gather from Curacao, just like PriceSmart, you can't go to the place and buy a pair of jeans because they sell in bulk or boxes. So the jeans, you may have 12 jeans, pairs of jeans in a box. They don't open the boxes at the warehouse. All right. So when you go to the walk to purchase it, so they don't open the boxes at the warehouse. So if you're buying jeans and it's 12 coming there, that's why oftentimes when you're going to Curacao, you have 3 and 4 heelers going together. So they may say to themselves that here the plan, go on some jeans to the store, and say, you're not buying no jeans. Them say, yeah, man. And I say, but guess what? No, the jeans come in, it's 12 coming there, and it's only 4 different sizes coming there. So we have to agree, so you can't get all of the small size. But I forgot mix it up. I say, yeah man, sister, what do you mean? Who want to take all of the small size? I don't know the small people come to me. No man. So when you purchase the box of jeans now, because it is like duty free, like when you go up on the plane and buy them something or in the airport and buy this stuff, they don't give it to you necessarily. You'll have to collect it as duty free. You don't pay any tax on it. Yeah, so then pay, but of course it's more expensive if you ask me, right? So you'll have to give them a shipping address and support, and it's sent directly to the airport for you, right? So you can't tamper with the stuff, right? That's exactly what it's like. So you will have to go now with your brethren. So this is why they do the plan or something. And I say, either plan, but they want to go, and then we're gonna share everything. So then get a little Airbnb, and the four of them lock up in a one room because them just want somewhere to sleep, because them are going to on the road from morning till night. Cause shut them a shop to come back to Jamaica, right? That's what them do. So what they do is buy the item, but sometimes they don't take a lot of things into consideration. I'm working with me if I'm making sense. Why am I telling you this? Because we're talking about optimization. Tell me if I'm making sense now. They have to take your Jamaica for go Curacao. Plain money. Them don't have nobody at Curacao, so them have to go rent an Airbnb at Curacao. All right? Them they need transportation. Them they need food. Them they need spending money. All right? Curacao now, I don't understand how them do it, but when you reach at the airport to come back, the man might charge you a departure tax. And I'm saying, why don't you just charge us in the plane fare? Them say, no, the money have to stay right there, so we want the money right there. So you have to pay them a departure tax. So they said, then suppose you not have it, you can't leave until you get it. It's like, okay, boss. So they have to take care of that departure tax and then leave in Cayman, and in Curacao. They have to also know, because they know that they're commercial, when they reach Jamaica, they have to pay duty on the items purchased. So their receipts must be kept. So me come from my field a while ago, 7 different costs me come because plus when they reach Jamaica, they have to go rent Ryan and him Noah to come pick up the 2 barrel them. That's another cost. All right? And then now when the barrel them go a yard and on a share about who forget this or who forget that, then now there may be another cost to transport the goods now from your house to what do you call it? To your place of work, to the arcade. So you have several different costs coming in. Now you have to be careful now. When you sell the item, a piece of the profit is supposed to come out to buy back the airfare, a piece of the profit come out to do the buy back the item, piece of the profit come out to the food we spend, so that every time you sell an item, you're actually building back your resources to go back into purchasing your airfare so you can start the process all over again to continuously replenish your area. You may be able to save on something because Aviana may decide that you're the plan. You go Curacao, so I'm not ready to go Curacao yet, but where I go buy? Why some more couple of jeans? Some going to take a box of jeans, all right, I'm gonna give somebody to buy a box of jeans in here, yeah, but sister, you have to go pay the duty. Yeah, man, that I know that man, that you pay the duty, man. So, Abby goes up and she buy the stuff. So you save your pain for this time around, right? But there's going to be other costs to the stuff. So when the man them sell the stuff, sometimes you wonder why they're out of business so quickly, because they don't apportion the money. And not every money will come in are yours. Not because are you selling. No man. If you don't apportion the stuff, your business may fail. Does that make any sense to anybody what I'm talking about?
Yes, sir.
Come on. And that's why a lot of small enterprises fail, because they don't have that sort of forward thinking. They don't have that sort of forward thinking, right? So they need to come and to Excel and do the optimization so they can benefit from you guys, to see exactly what it is. So this is what the topic is. Nothing more than it, but this. Any question? Or any other question? Any other question? No? All right. So I have 20 minutes. Let me just introduce this now so that come next time around, we have more time to just maybe look at some past papers. Boy, sir, you know, I know you just a kill with the motor variable function. Yeah. When you look at the syllabus, it is, which is I need to go back and look at the syllabus. It has a whole lot. The longest unit is this unit. Explain that to me, Yannick.
So it's cost and management accounting.
Oh yeah, you see that's why the bright people do accounts and the ones that are not so bright do math. But yes, you are correct. So in business calculus, they have something that is called cost and revenue function. So you know your revenue is going to be equals to your profit plus your profit is going to be your revenue is going to be equals to your cost and what it is that you're going to get out of it, right? So you have to be able to do your marginal profit and your marginal cost, your marginal revenue, and all of them something there, because there's going to be an overhead. There's one other overhead, as I see you put there, Yannick, that I didn't talk about. And you know, I'm happy that you said that to me, Yannick. You know why? It shows you that what it is that they teach you in accounting is is I am making some connections with it with the mathematics. And this is how personally I would have loved if my math teachers taught me. I learned mathematics in isolation. And it's because I had a mathematical mind why I appreciate the math so much. Some of my friends just couldn't relate to the mathematics. And when I became a teacher, I said, look, I've got to make connections. If I'm teaching in cosmetology that I did for many years, I learned there's terminologies and stuff so I can relate the math to what it is that they are doing. When I went and taught math to the tourism people, I related the mathematics to what it is that they are doing, right? So you have to relate it so that you can see what is happening. So there's one other company that I didn't speak about. When the man them reach or them stall a town, them have to pay rental for them space. That the money have to come out of it too. The man have to get electricity. That the money that have to come out of it too.
Protection money, sir.
Is it again?
Protection money.
Oh, truth. And that's why this teacher, and I want to go on record, will never, ever do anything like that. Because guess what? I know me, and I'm going to say to you that when I'm toiling, you were not there. So we're not giving no protection, not me. And there says when it start a whole lot of problems. So because I know that, it's best for me not to get into that business. Real talk. Real talk. And the truth of the matter, if you don't pay that protection money, you think they're going to miss you. And it's really very sad. Really very, very sad. Right? So being a business owner in this country is not a desire of mine, because you need not me to come knock on my door and say, oh, I want to say, and me run the place, you know. And at night time, me watch out so that nobody can do that, you know. You need to go up on a payroll. Which payroll? My payroll? Do you have an ID for the workplace? You can't go for the payroll. I mean, it's going to cause problem. It's going to cause problem. So guess what? I have absolutely no desires, absolutely none. I mean, I've heard horror stories of people who are in high places to say that when the bill and receipt come from the payment, or say, oh, in a hospital and they want this, to go to that. Oh, no. If a student come to me and say, boy, I teach, say, want a laptop to go to school, not a problem. But you're not going to extort out of me. So because I know who I am, I better be sitting and just teach and take the abuse from teaching. Real in order to live. So I'll take the abuse, as much abuse I can take. And when I can't take the abuse no more, I say, you know what? Goodbye. Time for retirement. But we're not all on business. I'd rather do it in the States. Real talk.
You can do it online, sir.
To be honest with you, you can do it online, but sometimes it, the clientele, well, I mean, I think you're right. That's the way to go. You can do it online. But to have a physical space to do the stuff, a man knows, and, like where I'm living, there's a complex that is being built a couple residents from me. And I remember I was doing some work at home and just left home to go and buy some stuff, and came back. And one of the workmen I saw, was having a conversation with one of the policemen. And I was like, okay, what's happening? So I drove in and he said, boy, boss, you don't know what happened. He said, what happened? It was a Friday evening. Um, the guys, it's some Chinese people them doing the thing. Of course, them don't want to pay the bank fees and so forth and so on. So they will go to the bank to make a large withdrawal. And then make the large withdrawal to come now to the place of construction to pay the people them. And of course, word get out to say, you need drive on red car, and she go on a bank, and she go come on the avenue here. So as they got to the gate, gunmen on motorbike just hold him up on the circle of the money. Just hold him up. And of course, it has to be somebody who is there who knows that they're going to the bank at that time to get the stuff. So because of that, now the construction went on pause for quite a while, and nothing was happening. So there's something there I don't want to get. We dropped down dead long time. I don't want to be part of that. Negative. But anyhow, your small business venture creation, such a new venture creation course that you have to do, it is very important that we teach you guys to become entrepreneurs. Don't be like a teacher who's sitting and working for people, or you're in a position to know that you're working for others. But we need to find ways of creating opportunities for ourselves. It's very important. See if you can build something and you have your own brand. So yes, Yannick, I agree with you. I could do something. I could start an online school since I may be good at what I'm doing, or can reach students, or I can become an advisor, an academic advisor, or whatever it is. I can find something because anything you want online, you can find it. All right, you just put in the information and Google. Once it is that you will know how to put your coding when you're putting your stuff there. You can get your products, goods and services right there and then. What I find now happening is a whole lot of courier services are now in Jamaica. So it's not the normal ship me or mail pack or whoever else there. So many other courier services are in. You understand? All the man them do is just go down South Miami and just rent one of the warehouse spaces. Right? If that's all you need to do. You just rent a warehouse space right there, and when a client comes, you just give them the mailbox address, and the item is delivered to the warehouse. And then you start to say, okay, this is going to Kingston, Jamaica, and then you say to them that Air Jamaica Cargo, or American Airline Cargo, or DHL Cargo. You may say, or FedEx. You may say, all right, how much is it to send 1 ton of things to Jamaica? And then say, okay, this is X amount of money. And they say, all right, fine. If the items come on a Tuesday, it will, or if it comes in on a Monday, we will get it by Monday evening to the airport. So we know that it goes to Jamaica on the Tuesday and to clear custom the Wednesday. So by Thursday, you can pick up the stuff. So when you go to these places, they tell you, once it gets to the warehouse in wherever it is, and needs the flight, another 2 days you can go and they can pick it up. This is optimization, because when they do things like this, the man them is getting their profit. So they will tell you what it is. And they're saying that if it is that it's over $50, then you have to pay a duty on that and rate it. So they man them optimize, and don't be surprised if the government is going to come in and change the regulations so that the government can optimize more on their profits. Optimization is what people look at, and people live off of. Right? They want to get the maximum out of it. Anybody ever go somebody offer some goods or services to you, and he say, how much is it to install a refrigerator? And they say, 20 grand, $20,000? No man, it's all right, boss. He said, no man, come over talk to man. How much you have? He said, how much you can take? He said, no, it's a reason, man. All right, give me 18. And I said, 18 are the best price you can go. I said, yeah, man, because on a me alone, I have 2 other apprentices that work with me, and I have to go pay them more time. He said, all right, me give it 18,000. You think the man could have charged you 18,000 from before? but the man is charging at a higher price because he knows that there's a
Yes,
possibility that you ain't call him down. True or false?
sir. True,
Go,
sir.
go ahead.
So what I'm saying, sir, in Jamaica, what I realize, like when you're selling, put say you purchase something for $5,000 and you want that an interest of $2,000. So that would have been $7,000. You have to put like a $3,000 on it because them are gonna ball it down.
Absolutely.
So yeah.
Absolutely. I don't know if it's this class at all. Was it this class, Lord? But listen again. One, oh goodness, what was it? Which holiday for me now? Not holiday. Them about something,
Labor Day.
not Labor Day, man. Them about October. Oh goodness. It's like Good Friday. Yeah, something like no man. It's like the Black Friday, like the Black Friday deal. Jamaica kind of latch on to the Black Friday deal now. So they have Black Friday sales in Jamaica. You know that, right?
Yes, sir.
So my wife and I one day went to this prominent store. We now call them name. Prominent store. And we said, but I was the one who said, no, man, the pot set look nice, We said, no man, come and go buy the pot set, man. And the pot set, well, they said that it was stainless steel, and it cost at that time less than $20,000. Let me tell you, it cost less than $15,000. With tax and everything, I don't think it'll reach $15,000. All right. And I said to her, that is a good buy. And she was like, no, man. Because guess what? In another couple of weeks, literally, they're going to be having Christmas sale. I said, are you sure? She said, yes, man, they're going to have Christmas sale. So I said, all right, then we could do. She said, all right, come and do something. Make me take the picture of the something, and then we're going to come up in at Christmas, and we're going to see how much it's gone to. So can I tell you? We took a photograph of it. Went back in Christmas to look at the stuff. Can I tell you that the price of the thing went to about $25,000 plus? $25,000 plus. And then now they're saying that you can get a 15% discount on it. And I'm saying to myself, what a wicked set of people.
Sir, you know what them do?
All
right, so them say you say 15,000 including tax. What them do, them hike it up, say about
absolutely
35%. And then mark off 15% off it, and then tell us say you get a 15% discount.
Absolutely. Absolutely. No, them things are smart. But them can't smarter than me, man. Absolutely. That's exactly what they do. So you see when fashion night out come and people think they might get deals, hello, if you weren't eyeing the item before, there is an increase in the price. Hello, times are hard enough. You think that people just about get up so and just give a 15% of them sale? When we call it now, when pandemic come on, like the expensive and them in make money for sales because curfew they come at 2 o'clock in the day and they have to lock up from 12 o'clock and it doesn't happen like that because everybody goes into a business to optimize. Optimization is what people try to do. So the man will come out, and as a matter of fact, you know what is also true? If Rashim called him and say, Mr. Shand, how much is it for XYZ? And I said, at $3,000. He said, okay, fine. And then now when you go Rashim house, Mrs. Rashim living in a 3-story building. I don't care if it's rented here. I don't care if it's. He said, they can't charge you that $3,000. He said, boss, no, say, based on the level amount of work we have to do, now $3,000, it's only $5,000 now. He said, but Virginia tell me 2,000, he tell me 3. He said, well, I'm sorry, I'm not even because guess what? The man see I live in a big house, or the man may see I drive a big car and think that, wow, he might go hike the price. Right? So you have to be very careful. I mean, people just look at you and say, okay, you look like you can afford it. $10,000. How much?
That's why when you're buying
guilty of that, sir. Me guilty of that, because when me I charge my customer them for the graphic design, right? For the some artwork for them. You see, me realize that them look a certain way, say price I go up.
Looks like deceiving. Go next door. You saying something next door?
So I was saying that's why you mustn't speak standard English. You have to just write up and act like
listen
you
to
know.
me. My friends, them when me go to them say sometimes when we talking, them say they push me, literally shove me, if you know, hold on, go me drop, you don't open your mouth and talk nothing, I get them in staff, Won't call the name.
Sir,
No, yes, please.
sir, all of them don't know, you know what I'm saying? They want to say, you know, $500. I say $500. I'm gonna understand it before.
Dexter, we went the college. We went down for a conference at a particular place in a particular part of the island, and we're staying at a hotel. And the driver needed to. I said, "No, principal, the driver can't drive out. Principal, this is behind Jesus and turn right and then let's." And the principal said, "Yes, Mr. Sham, it's true." And I said, "Driver, you can't change over course." And driver said, "No, Mr. Sean." He said, "No, man, if you go down on the road unless you go find something so you can at least have something to, change over, so you can overnight, because it can make sense. You have to drive all the way, go back to Kingston and to come back the following day." I said, "No, that doesn't make sense." So principal agreed with the man and he said, "All right, Sir Sean, come. We're going to go down to the place to buy something." So of course, they have some troublesome staff members, and I just don't know why I am pulled into that category. So, a group of us went down to the west end of this particular place to purchase.
Sir Ghana or something?
You see, this computer don't want me to be great, That's why I'm going to change it. I not, man, in a computer. Sorry about that here. The system just went blank. That's why I have to use so many things when I'm doing this stuff. Sorry about that here. Yeah, man. So the staff member went down and we went into the store, and the staff member says, "How much is it for a pair of underpants?" Now we think that we could have bought a pair of underpants about $500, The lady looked at us because we went to a hotel and it's a business meeting. So the one away well dressed, well dressed, And the lady said to one of the staff members, a female staff member, $1,000. And that staff member said, $1,000? Sean, come. We now buy. Just like what Dexter said now. We can't get that for $300 down the road. And me afraid, because I am in this part of this Jamaica that I don't know. And but this person is from that area, so she knows the area very well. And the truth of the matter is, we were able to find another store that we got about 4 pairs for about $1,000. So you have to, people look at you and and already decide that me going pay my mortgage after you $2,000, when in truth and in fact it costs $200, and because you're not even very mindful of it, you get exploited. It happens when I go to the market. So I don't want to see none of you when I go to the market, because I no longer wear nice looking sort of stuff. You can't identify me because I have to look like a market person. Because when I go there, them said, "How much is for this coconut?" $600. It's like, whoa, what we want a $600 coconut? And then when it truth in fact is when you go to the other customer or to, the other vendor to buy something, how much for your coconut? $150. He said, but why you start with 600? Master, go on more business and $600. So yeah, people just look at you and they say, boy, you ain't have to spend much more money on an item because everybody is trying to optimize their product, their services, their return. So think about it. That brings us to the end of that section on optimization. The truth is, what we have left is from the system is coming up. From what I'm seeing there, well, to look at SI and matrix, I'm not going to be spending a lot of time on the SI matrix because it's on the syllabus. But as I said before, I've never seen it on an exam paper, but I want to teach it because I don't want any complaint to come in to say, sir, never did teach you this topic and it came on the exam paper, because I'd have to say it's true. So I want to look at it. Then I'm going to use a little bit of the time just to scan through again the syllabus, just to make sure that I would have covered all the areas. You too can go ahead and do the scan through just to make sure that things are there. If you're seeing something that, we never complete, you say to me, sir, we never did this. But importantly, thanks again, Ryan, for posting those past papers in the WhatsApp group. Importantly, every Jack man and woman in this class should find a past paper question from the group of questions that we have and start working on it for class on Thursday. Because at some point in time during the session, I want to spend even an hour out of our time on Thursday, God Sparing Lives, to do some past papers. We have to spend some time doing some past papers. And I said before, I will avail my time and myself to you come next week, just to go through the additional past paper questions with you. If you don't want me, it's not a problem. But I want to just spend some time so we can just go through those so that we can be fully ready. When is the exam? Which date are you seeing for the exam?
27.
27, sir.
Oh, that's all the way down there. No, that's not all the way down there. The 23rd is the Tuesday. Oh, the 24th is a Tuesday.
Is that Friday?
The 27th is in the first week. Them play so rough. Them play rough, man. It's the first week. Them put in the calculus too. All right. All right, here's the plan. Do what it is that you need to do. On Thursday, let us do some mop-up. Because as I said before, we've been doing pretty well. One good commendation from the group is that I was in a session with some other lecturers and I was saying to them that I have a class from 7 to 9 on a Thursday. And they said to me, then students really come to 7 o'clock to 9 o'clock, 7 o'clock to 10 o'clock. They really come to a 7 o'clock to 10 o'clock class. And I was able to use that opportunity to talk about my calculus 2 students. You guys come out for the most part. One or two of you have slacked off on it, but for the most part, you guys come out, and I can tell you, I know that learning takes place or can take place in this online medium because I've seen where you guys have learned and are learning. So do me a favor. I want you to assist me come Thursday, God's willing, just by looking at some of the stuff to see where it is that you are not fully there, so that we can go through. All right? Have a good one. Bless up.
Hold on, sir. Hold on. I want to test.
All right. So I got a telephone call on Sunday when yours truly took out my ladies. I was way, way, way in the deep bushes of St. Anne. And I honestly to God just did not remember. I apologize. It definitely has to be this Thursday because this is the last teaching week. It has to be on Thursday. I apologize. I just never remember it was Mother's Day and a student said, but sir, I said it. I just didn't hear. Had I remembered that it was Mother's Day, I know what the plans I had, I wouldn't have put it for Sunday. I apologize. So definitely it has to be for this Thursday. Hands down, no other delays, has to be for this Thursday. All right?
All right, cool stuff.
Thank you. Cool.
What time Thursday, sir?
I wouldn't put it at Rika, I wouldn't put it at 7 o'clock because I know we're coming at 7 o'clock. So it will be in between when I know that everybody is there. That's all right?
Okay, sir.
Yeah, man. All the best here, guys. Thanks much.
All right, sir.
Cool.